Let's talk about something we all use but rarely consider: bridges. Every day, millions of us cross bridges without a second thought, whether we're heading to work, school, or just running errands. They're so much a part of our daily routine that we barely notice them, until something goes wrong. Think of the Golden Gate or Brooklyn Bridge, icons that connect millions of people every day. These aren't just landmarks, they're lifelines, keeping cities and communities connected, and making modern life possible. These structures are the arteries of our nation, vital to our daily lives and economy. Without them, goods wouldn't reach stores, people couldn't get to their jobs, and entire regions would be cut off from each other. But here's the scary part. Many of America's bridges are old, built for a different era, with less traffic and milder weather. Some of these bridges were constructed over half a century ago, when cars were lighter and there were far fewer of them on the road. Decades of rain, snow, salt, and pounding traffic have worn them down. Every winter, road salt eats away at the metal and concrete, while heavy trucks and constant vibrations slowly weaken their structure. The materials we've relied on, steel and concrete, don't last forever. Steel rusts, concrete cracks. Over time, even the strongest materials can fail if they aren't properly maintained or replaced. Small issues can quietly grow into dangerous problems. What starts as a tiny crack or a bit of rust can, if ignored, turn into a major structural weakness that puts everyone at risk. Potholes, rust stains, and weight limits aren't just eyesores, they're warning signs. They're signals that a bridge is struggling to keep up with the demands we place on it every day. This isn't just about famous bridges, it's about the thousands of smaller ones we all depend on. From rural back roads to suburban neighborhoods, these bridges are essential for school buses, ambulances, and delivery trucks. When a bridge fails or closes, the ripple effects are huge. Longer commutes, delayed emergency services, and economic headaches. Businesses lose money, families lose time, and entire communities can be thrown into chaos. We've been patching up the problem for years, but that's not enough. Temporary fixes might buy us time, but they don't solve the underlying issues. Sooner or later, the problems come back, often worse than before. The crisis is real, and it's happening right under our noses. Every day we delay, the risks and the costs grow higher. So, what if we could do more than just patch things up? What if we could rethink how we build and maintain our bridges using new materials and smarter designs? What if we could build bridges that last for generations? Imagine a future where our bridges are safer, stronger, and built to withstand whatever the world throws at them, ensuring that America stays connected for decades to come. Just how serious is America's bridge problem? Let's break it down by the numbers to see the true scale of the challenge we're facing. Across the United States, more than 46,000 bridges are officially classified as structurally deficient. That means they're in urgent need of repair or replacement to remain safe for daily use. These aren't just minor cracks or cosmetic issues. Many of these bridges have significant structural damage, from rusted supports to crumbling concrete, putting millions at risk. The average American bridge is now 44 years old. Most were designed for a lifespan of about 50 years, so many are rapidly approaching, or have already passed, their intended limits. As time goes on, the risk of failure only increases. Every single day, Americans make 178 million trips across these aging structures. That's commuters, families, school buses, and freight trucks, all relying on bridges that may not be up to the task. The repair backlog is staggering. Over $125 billion is needed just to bring our bridges up to standard. And that number keeps growing as more bridges fall into disrepair. Instead of investing in comprehensive upgrades, we're spending huge sums on temporary fixes, patching rust, replacing individual parts, and making stopgap repairs that only delay the inevitable. This endless cycle of patchwork repairs is both inefficient and incredibly costly. It drains resources without providing lasting solutions. As a result, sudden closures, detours, and constant construction zones have become a frustrating part of daily life for millions of drivers. These disruptions don't just waste time, they slow down deliveries, increase fuel consumption, and cost our economy billions in lost productivity every year. The price we're paying for our aging infrastructure is steep, and it's only getting higher as the problem grows. The reality is, this problem isn't going away on its own. In fact, it's getting worse with every passing year. To truly solve it, we need to move beyond short-term fixes and invest in long-term, durable solutions, using modern materials and innovative engineering. By building bridges that are designed to last for generations, we can ensure safety, reliability, and economic growth for the future. The numbers don't lie, America's bridges are at a tipping point. We can't afford to wait any longer to act. So what's the solution to the age-old problem of bridges wearing out before their time? For decades, engineers have searched for ways to make our bridges last longer, to withstand the relentless assault of weather, water, and time. The answer is simple in theory, but revolutionary in practice. Build better bridges, with better materials. It's about rethinking the very bones of our infrastructure. Enter a new kind of steel, meticulously engineered to last not just decades, but a century or more. This isn't the steel of the past, it's a material designed for the future. The secret lies in the alloy. By adding elements like chromium, copper, and nickel, scientists have created a steel that forms a unique protective patina on its surface. This isn't just chemistry, it's innovation at the atomic level. Instead of rusting away like ordinary steel, this advanced material develops a tough, invisible shield that blocks out moisture and oxygen, the main culprits behind corrosion. And here's the remarkable part. If the surface is scratched or damaged, the patina reforms all by itself, giving the steel a kind of self-healing property that was once thought impossible. This is a leap forward in bridge technology. Now, bridges can defend themselves against decades of harsh weather, pounding rain, freezing snow, and even the corrosive effects of road salt. The manufacturing process is tightly controlled from start to finish, ensuring every beam and girder meets the highest standards of strength and durability. Quality is built in at every step. This isn't just a minor upgrade, it's a fundamental shift in how we think about building for the future. Old bridges crumble and rust, but these new structures are built to endure. Imagine bridges with their own immune system, standing strong and safe for generations to come. It's a vision of infrastructure that serves not just us but our children and grandchildren. It's not science fiction, it's happening right now in cities and towns across the world. Engineers are already putting this new steel to the test. Early results are astonishing. This new steel could double or even triple the lifespan of our bridges, saving billions in repairs and replacements. It's a smarter, more resilient way to build, one that's ready to meet the challenges of a changing world. The future of infrastructure starts with the materials we choose. Every bridge, every city, every community stands to benefit, and this new kind of steel is leading the way, forging a path towards stronger, safer, and longer-lasting bridges for everyone. Lab results are great, but does this super steel work in the real world? Absolutely. The Keg Creek Bridge in Iowa is a prime example. Engineers use the new steel in the most vulnerable spots, girders and joints, while using traditional materials elsewhere to save costs. Sensors embedded throughout the bridge monitor moisture, corrosion, and stress 24/7. Years later, the high-performance steel shows almost no corrosion, while traditional steel nearby is wearing down. This success has inspired other states to adopt the technology. Each new bridge adds more data and confidence. The best part? This steel fits into existing construction methods. We can start building 100-year bridges today, using the workforce and equipment we already have. Real-world results are proving the promise. The future is already being built, one bridge at a time. Why does this matter? Because longer-lasting bridges mean safer roads and smarter spending. Structurally deficient bridges are a risk, rare failures but real danger. Building with self-protecting steel means peace of mind for generations. Yes, the upfront cost is higher, but the long-term savings are huge. Fewer repairs, less repainting, and less disruption save taxpayers billions. That money can be invested in other critical needs: schools, water, power. These bridges are also more resilient to climate change, handling harsher weather and corrosive road salt. Longer-lasting bridges mean less waste, less energy use, and a smaller carbon footprint. By doubling bridge lifespans, we cut environmental impact in half. It's about building smarter, more sustainable cities. This isn't just about bridges, it's about a better, more efficient way of life. Investing in new technology is investing in our future. The benefits go far beyond the bridge itself. Of course, there are challenges. High-performance steel costs more upfront, making it a tough sell for tight budgets. Only a few mills can produce it, so scaling up will take investment and time. It's a chicken and egg problem. Mills want demand, engineers want supply. Retrofitting old bridges is tricky. You can't just swap out steel. Sometimes only the most vulnerable parts can be replaced. Other times a full rebuild is needed. Policymakers are developing tools to show that long-term savings outweigh initial costs. Federal incentives can help mills upgrade and expand. Researchers are also finding new ways to strengthen old bridges with advanced materials. Overcoming these hurdles will take collaboration and smart policy. How do we make this the new normal? It starts with building confidence. Pilot projects like Keg Creek prove the steel works. Next, we need to update engineering codes and standards, a process that takes time and rigorous testing. Education is key, training engineers, architects, and workers to use the new material. Universities and trade schools must adapt their curricula. Public demand matters too. When people understand the benefits, they can push for change. This is more than an engineering issue, it's a public policy choice. The journey goes from lab to field, to rule books, to public support. That's how we build a future with smarter, stronger bridges. Imagine a future where structurally deficient is history. Bridges aren't just strong, they're smart. Sensors embedded in new bridges create digital twins, letting engineers monitor health in real time. Predictive maintenance means fixing problems before they become emergencies. Smarter data leads to lighter, more efficient designs and less environmental impact. Bridges could even adapt to changing conditions, rerouting traffic to extend their lifespan. This is about more than steel. It's about resilience and legacy. The choices we make now shape the world for generations. Investing in durable, intelligent infrastructure is building a foundation for the future. A future forged in smarter steel is safer, more efficient, and built to last. Next time you cross a bridge, think about the engineering beneath you. We've built wonders, but time and weather are catching up. We can keep patching the old, or we can build for the future. New steel technology gives us a clear path forward. Bridges that protect themselves and last a century. This isn't science fiction, it's already happening. Transforming America's infrastructure will take investment and vision. The rewards: safer travel, smarter spending, and more resilient cities. The bridge to tomorrow is being built today, one project at a time. Every new bridge, every trained engineer, every informed citizen brings us closer. We have the tools and the ingenuity to build better. Let's create a legacy of strength and durability for the next 100 years. The future of America's bridges is in our hands.